Today we're going to talk about two things. We're going to talk about what makes a quadrilateral a parallelogram, and then we're going to talk about how to see if a quadrilateral could be a parallelogram. They're kind of converses of each other. So this is a parallelogram. I'm going to give you all of the characteristics that are in a parallelogram. And these are really important. So number one is the definition of a parallelogram. It says that both pairs of opposite sides are parallel. So that means if I'm looking at my figure, I know that these two are parallel and these two are parallel. That's a characteristic of a parallelogram. And all of the things we've learned in the past about parallel lines apply here. When you think about alternate interior angles and same side interior angles, those all apply. Number two, if you know a figure is a parallelogram, you know that both pairs of opposite sides, I'm going to abbreviate here, both pairs of opposite sides are congruent. So that means this one's congruent to this one, and this one's congruent to this one. Both pairs of opposite sides are congruent. Next up, we know that both pairs of opposite angles are congruent. Both pairs of opposite angles are congruent. So this angle is congruent to this one. And then this angle is congruent to this one. The opposite angles are congruent. Number four, we know that the consecutive angles are supplementary. Those would be your same side interior angles. So an example of that would be this angle and this angle. These two angles add up to 180. They're consecutive. These two angles add up to 180. The consecutive angles are supplementary. And the last one is that the diagonals bisect each other. Diagonals bisect each other. Now you have to be careful on this one. We aren't saying that the diagonals bisect the angles. We're saying the diagonals bisect each other. So if I connect this corner to this corner, maybe I'll just draw it over here. So if I draw this diagonal and I draw this diagonal, those two just cut each other in half. So these two pieces are the same and these two pieces are the same. They bisect each other. They don't bisect an angle, they cut each other in half. Those are characteristics if you know a figure is a parallelogram. Those are all the things you can apply to that. And you'll get to practice those here on the next page. Now I'm going to jump over to page 8 on your note packet, and we're going to talk about how do I know if I gave you a figure and said, is this a quadrilateral? How would you be able to tell? Now, a lot of these are going to feel like the same thing I just told you because they're the converse of those rules. The rules I just gave you were, if a figure is a parallelogram, then both pairs of opposite sides are parallel. If a figure is a parallelogram, then both pairs of opposite sides are congruent. So all of these were, if it's a parallelogram, then these things are true. So we're going to switch gears to the converses to say, if both pairs of opposite sides are parallel, then it's a parallelogram. If both pairs of opposite sides are parallel, then it's a parallelogram. That's what it says down here. Like I said, most of these are going to be identical. If both pairs of opposite angles are congruent, it's a parallelogram. If both pairs of opposite angles are congruent, it's a parallelogram. If both pairs of opposite sides are congruent, if both pairs of opposite sides are congruent, then it's a parallelogram. If the diagonals bisect each other, then it's a parallelogram. So far you're saying these are the same things we just wrote. What's the deal? Here's the different one. You have to pay close attention to this one because this one's a little bit tricky. This one says if one pair of opposite sides is congruent and parallel, then it's a parallelogram. So that means I've got a shape here, and I told you that the top and bottom are parallel, and I also told you that the top and bottom were congruent. That's a parallelogram. If I told you that the top and bottom were parallel and the right and left were congruent, that is not enough information to prove that this quadrilateral is a parallelogram. So be really careful. It has to be the same pair of opposite sides. So here we go. Let's practice a couple of these. So first off, we have this shape. Let's pretend like I told you the top and bottom were congruent. We're going to try to figure out what could make this into a parallelogram. Well, one choice would be if the opposite sides are congruent. Well, I don't have any way to prove that the left and right are congruent, but I can use these two angles. Remember our same side interior angles? If these two angles add up to 180, that makes the lines parallel. So that's what we're going to do. We're going to add up these two angles, make them equal 180, and that's going to make our lines parallel. So 3x equals 150. So if x is 50, that means this angle would be 60 and this angle would be 120. That would make the lines parallel, and that would make this a parallelogram. All right, next up, number 2. Notice I have hash marks on this diagonal. So this diagonal has been cut in half. Well, in order for this to be a parallelogram, I need the other diagonal to also be cut in half. So all I have to do is find out what value of x would make these two segments the same. So I subtract x, I add 6. If x is 8, this would be 34, this would be 34, and I would meet rule number 4 that says if the diagonals bisect each other, then the quadrilateral is a parallelogram. Okay, now we get to the really fun part, which is an actual proof. We are actually going to prove that something is a parallelogram by making one of those 5 rules true. So let's take a look at our picture. In the given, it says that DEBF is a parallelogram. So all of the properties that I told you on the first page of notes are true about that shape. Can I prove that ABCD is also a parallelogram? So we're going to start with number 1. DEBF is a parallelogram, and AE is congruent to CF. That's going to come in handy. AE equals CF. That's our given. So let's think about our rules. If I could prove that both pairs of opposite sides were parallel, but I don't think I can do that because I don't know anything about CB and DA. Can I prove that both pairs of opposite sides are congruent? Again, I don't know anything about DA and CB. I don't know the diagonals. I don't know the angles. I think I'm going to go for the rule that says one pair of opposite sides is going to be congruent and parallel. Let's see what we can do with that. Well, first off, if DEBF is a parallelogram, aren't these parallel? That's the definition. So I'm going to say DF is parallel to EB. Now, by saying that, I'm also saying that AB and DC are parallel to each other, because they're just a continuation of those lines. So I can put that here. That's the definition of a parallelogram. Both pairs of opposite sides are parallel. Opposite sides parallel. Now if I could somehow prove that DC and AB are congruent, I'd have myself a parallelogram. So let's think. What can I say about segment DC? Well, I can say that it equals DF plus FC. What can I say about AB? Well, AB equals AE plus EB. Remember from a long time ago, that's called segment addition. Now, I need to prove that DC and AB are equal to each other. So let's look back at the given. I know that AE and CF are the same. AE and CF are the same. Well, don't I know that DF and EB are the same? Let's say that. Since DEBF is a parallelogram, the opposite sides are congruent. So I'm going to go ahead and say that DF equals EB, because in a parallelogram, the opposite sides are congruent. All right, now we're going to use the magic of substitution. The yellow segments are equal and the green segments are equal. So I'm going to say that DC equals, I'm going to substitute EB in place of DF because they're the same thing. And I'm going to substitute AE for FC because they were equal. That's substitution. You can take something out and replace it with something that it's equal to. Now notice that this DC and that AB are the exact same thing. So I can say that DC equals AB. Again, substitution. And now I can finally get to my point that says ABCD is a parallelogram, because I just proved that one pair of opposite sides was congruent and parallel. Phew. They're not all quite that complex, but there you have it for this one. Do some practice on this and see how you do.